Len Fisher, The Perfect Swarm, The Science of Complexity in Everyday Life. In The Perfect Swarm, The Science of Complexity in Everyday Life, Len Fisher delves into the fascinating world of swarm behavior and its applications to human society. The book explores the complex ways in which individual actors within a group can respond to each other, ultimately leading to collective problem-solving that outperforms even an expert's capabilities. As you read the summary, you'll discover how aspects of these rules can help create order from chaos in various aspects of life, and what we can learn from the behavior of nature's swarms. You'll also gain insights into how to navigate crowds, employ optimal decision-making strategies, and make sense of complex data to inform your daily life.
The Science of Complexity. The science of complexity analyzes the patterns and processes of self-organization that allow complex structures and relationships to emerge out of chaos without a central director. Swarm behavior becomes swarm intelligence when they collectively solve a problem that individuals could not. Systems exhibit two types of dynamic patterns, cycles, and adaptive systems, where the elements in these systems adjust according to changes in circumstances. Adaptive systems tend to have certain kinds of relationships among the individual components that produce swarm intelligence. However, positive feedback and chain reactions can cause systems to fall apart. Negative feedback stabilizes destabilizing forces, and it balances prices in the economy after a period of instability or disturbance. The collective behavior of humans and bees. The movements of humans and bees follow self-organizing principles when reaching critical population densities. Bees swarm according to avoidance, alignment, and attraction to other bees and a target. Similarly, humans follow a leader without realizing it. In a social experiment, social psychologist Stanley Milgram found that when one person on a sidewalk stared at a window, 40% of pedestrians joined, while 5 people staring led to 90% joining. The idea that a small early adopter group can lead to a larger acceptance cascade applies not only to crazes but also human behavior. The Lessons from Ants. This book excerpt draws fascinating parallels between ant colonies and human communities, highlighting how ants use pheromones to find scarce resources and form efficient traffic lanes. The author also examines the impact of community interactions on websites and the importance of tallying in guiding our decisions. The excerpt concludes with life-saving lessons from ants for individuals caught in panics, emphasizing the significance of following the swarm and planning emergency strategies in advance. The book offers excellent insights to help readers succeed in the market and navigate challenging situations by drawing inspiration from the cooperative and resilient nature of ants. Group decision-making. To make effective decisions in a group setting, it is essential to choose the appropriate method based on the type of question being addressed. For estimations, collecting individual responses and averaging them out provides the most accurate result, while voting is more suitable for multiple-choice questions when the group is well-informed. Expertise is crucial, particularly when dealing with complex issues at the intersection of knowledge and initiative. A group of experts usually performs better than a solo expert, and a group, in general, surpasses most individual members. Patterns help guide through complexity. Group decision-making, voting, debating or swarm intelligence. Making decisions as a group can be a challenging task due to different opinions and ideas among members. This book emphasizes the 3 choices that groups usually have, including following the will of the majority, debating the issue until they reach consensus, or using swarm intelligence. The author mentions that both humans and animals tend to follow the majority, leading to the quorum response, which is quick and easy but subject to the voting paradox. The author recommends adding independent action, such as gathering information, to improve the results of voting or following the crowd to prevent manipulation. Debating issues poses the danger of groupthink, in which group members adopt a shared conclusion and abide by it regardless of evidence. To address this, group members should gather information independently, work through its implications, and then present findings to the group for evaluation. Finally, swarm intelligence involves individuals spontaneously and voluntarily interacting to solve problems. Individuals in a swarm are more likely to share their power, leading to a more collaborative approach to problem solving. Networks and their necessity. Networks consist of nodes representing individuals and items, and connections representing relationships among them. There are deliberate and random networks providing simple rules that steer us through enormous complexity. Network connections tend to cluster in a power law, and hubs stabilize the network. Some elements of a network function as isolated islands, and focusing efforts on hubs is necessary in everything from public health to marketing. To spread news of a product or service, identifying and informing the hubs through well-connected individuals can be crucial. Networks are significant in human lives, and they come in different shapes and sizes. For example, according to the book summary, an individual's network may comprise their family, friends, co-workers, and people they meet randomly. These networks can either be deliberately planned or can manifest randomly. Networks are made up of nodes, dots that act as representations of items or individuals in the network. Connections among the nodes are depicted by lines. The distribution of network connections isn't linear. Some nodes have many more connections than most, and networks tend to cluster according to a power law. These hubs stabilize the network, and its destruction depends on the functionality of its stabilizing hubs. To help sustain the network, it is crucial to identify the areas that promote the network most and focus on their development. Additionally, a network with well-connected individuals is a helpful medium for spreading news of a new service or product. Instead of merely contacting many people to get the word out, it is best to identify hubs or well-connected people and inform them. It is imperative to note that these well-connected individuals have many demands on their time, and informing them/utilizing them may determine the success of the message delivery. Deciphering what's important. In a data-driven world, it can be challenging to identify what information is truly essential. The book suggests applying a gold miner's approach, wherein one should collect initial treasures, filter through the data until valuable insights appear, and then look for patterns in the remaining data. However, finding a pattern doesn't always indicate its significance. The book recommends conducting experiments and using statistics to evaluate patterns' worth. Additionally, the book challenges the notion of more is better. It introduces 5 heuristics for efficient decision-making: recognition, fluency, tallying, take the best, and satisficing. These heuristics simplify complex scenarios, and one can use them to make quick and accurate decisions based on what's vital. The heuristics require choosing the recognized option, going with the familiar option, listing the positives and negatives of each choice, selecting the one that has more essential attributes, and opting for a solution that exceeds one's expectations. These simple yet effective strategies can help in distinguishing what's crucial in a barrage of data.
Having uncovered the intriguing science behind swarm behavior and complexity in this book, you can now appreciate how these patterns and processes occur in everyday life, shaping our world in ways we may not even realize. Key lessons include understanding how swarms coordinate and exhibit intelligence without a central director, identifying the types of systems that govern our world, and appreciating the importance of our interconnectedness through networks. By applying the right approach to decision-making and drawing from nature's swarms, we can make better choices in a range of situations, from navigating crowded cities to solving complex problems using collective intelligence. Overall, understanding this science unveils a myriad of insights that can help us navigate a complex world and make more informed choices.